Hi everybody. Today we're going to go through how to find the number of protons, neutrons, and electrons using the periodic table and the squares on the periodic table. So today I'm going to show you this presentation that I made, and you're going to get homework that looks just like it very, very soon. So use this video because it will mimic your homework for today. So it does involve a little bit of math, not terribly hard math. And a calculator is acceptable to use. So you're going to use the periodic table, which I actually provided for you, and a calculator to complete. So here we go. Let's try the first one. So the first element we're going to look at is helium. Helium, if you look at a real periodic table, the full one would be on the upper right-hand corner of the periodic table. It has a special number, number 2. We see its symbol here. We see the name helium at the bottom, and then we see the special number as a decimal, 4.00260. Now, every element has a different number in each of these spots, but this is the atomic number, and this one is called the atomic mass. All right, so your job is going to be to use the information here, and it doesn't look like there's a whole lot, but there's a whole lot on there, and then fill in all this stuff over here. So here we go. If we look for the element name, we see it written here. So what I would like you to do is to type in helium, and we shouldn't have any spelling errors because you just need to copy the word over here. We see its symbol here. Now this one has a capital H and a lowercase e, and that does make a difference. If it is a 2-letter symbol, it would be a capital lowercase. Below that, we see atomic number. Now, the atomic number is this one up here in the corner. It tells you the number of protons in the nucleus of the atom. So we see helium's special number, or atomic number, is the number 2. That does mean that there are 2 protons in the nucleus of an atom of helium. All right, then here we have what we call the atomic mass. This is essentially how heavy it is. Now, we talked about this before. We weigh them in atomic mass units. We needed a new unit because they're so light that nothing in the metric system could be used to measure. So it's atomic mass units. But again, this is how much it weighs. It weighs 4.00260. So I'm going to write that decimal in here, 4.00260. And I'm not going to round it. And if you want, the unit is atomic mass units. That's the abbreviation we put behind it for atomic mass units. Then it's going to be important for us to always round that atomic mass number. And that's going to come in with our calculations actually for the number of neutrons in a minute. So we're going to round that. And if I look at the number, I want the closest number, it's 2. So 4.00260, that is closest to either 4 or 5, and that is definitely closer to 4. So I'm going to put the number 4 there. So now I've rounded that atomic mass number. So let's calculate our protons, neutrons, and electrons. So protons is easy. Protons is always the atomic number, whatever's up here in the corner. So this atom of helium has 2 protons in it. And then I'm going to actually skip down to electrons for a minute. And the number of electrons always equals the number of protons. So if you remember, protons are positive and electrons are negative, and the positives always equal the negatives. So since I have 2 protons, I will also have 2 electrons. Now, neutrons is just slightly more complex. It is not the number 4, and it is not the number 2 here, at least not as they're written. So I told you that this is the weight of an atom of helium. If you remember, protons and neutrons are fairly large molecules compared to electrons, which are so much smaller, like 2,000 times smaller. So when we see the weight here, it is the weight of the protons and neutrons and electrons together, but electrons weigh pretty much nothing, so they hardly adjust this weight at all. So if I know that I have 2 protons, and I know this whole thing weighs about 4, I need to take the weight, the atomic mass, minus the number of protons to figure out how many neutrons I have. Well, I can do this one in my head. 4 minus 2 is 2. So this atom of helium has 2 protons, 2 neutrons, and 2 electrons. Now that math was fairly easy, but I linked a calculator for you, and I'll click on it to show you. If you need help with that math, it's going to go ahead and give you a calculator that you can go to. And if you needed to check that 4 minus 2 is 2, then you could have found it that way. All right, next one, carbon, I see over here. All right, so let's start filling it in. I see that its name is carbon, so I'm going to type carbon in here with no spelling errors. I see its symbol is C. Now, a single letter symbol is a capital letter. It is not. See, that's not lowercase. We don't want lowercase. If it's a single symbol, it's an uppercase. The atomic number is the number of protons it has. So I see it's a 6 up here in the corner. And then the atomic mass written as a decimal, I see 12.0107. So I'm going to write 12.0107. And that was atomic mass units. All right, now I need to round the number 12.0107 to the nearest whole number, and that is closest to 12. And then I can go ahead and start to figure out my number of protons, neutrons, and electrons. Well, the number of protons this time was the atomic number up in the corner. It's a 6, so I put a 6 here. Remember, the positive always equal the negative charges, so the number of electrons is also 6. Now we got to do a little math, because this is the weight, how heavy this atom is. I rounded it to 12, and I'm going to subtract off the number of protons to find how many neutrons there are, and 12 minus 6 equals 6. So this one, too, has 6 protons, 6 neutrons, and 6 electrons. 6, 6, and 6. That's interesting because the last one we did was 2, 2, and 2. But please note, it is not always the same, and we'll see that on our next element. All right, here's our next element, chlorine. Let's start filling in our box. I see that its name is chlorine. I'm going to spell that right. I see its symbol is capital C, lowercase l. I see the mass number up here. We're getting a little bigger, is 17. And I see that the atomic, or excuse me, I said mass number. The atomic number was 17. The mass number here, it's not quite as long of a decimal, but it's 35.453 atomic mass units. All right, now this one maybe is a little trickier to round. So I have to consider it's 35.4. Okay, well, 4 is less than a half, so this rounds to 35. All right, number of protons, neutrons, and electrons. Well, protons is just this number up in the corner, so 17. And electrons always equals the number of protons. But now I've got to do a little math. I take my rounded atomic mass, which was 30, oops, sorry, I skipped the screen, which was 35. So I'm going to type that there. I don't know why I skipped the screen again. We can try it one more time. All right, let's try it one more time. Let's type 35. Hey, it worked. And I'm going to subtract off the number of protons. So I need to figure out what 35 minus 17 is. So if you can't do that in your head, or go ahead and click on your calculator, and let's check 35 minus 17. 35 minus 17, and hit my equals button. It equals 18. So I'd go back here, and I would type 18 in there. See how this one is 17, 18, 17? They don't have to be the same number. All right, last example problem is silver. So silver gets a little bit bigger. Look at the numbers, 47 and 107.8682. Those are much bigger numbers than we used before. We can do this. All right, the element name, silver. Its symbol, Ag, capital A, lowercase g. The atomic number is this one up in the corner. It's number 47. That's got a lot of protons in the nucleus. 47 protons in the nucleus. The atomic mass before we round it, 107.8682 atomic mass units. And then the rounded atomic mass. So I need to round 107.8. Now that's bigger than a half. So this would round to 108. All right, the number of protons is always the number in the corner, so 47, and the number of electrons always equals the number of protons, because positive cancels out or equals negative. All right, so now to find the number of neutrons, I take my rounded atomic mass, which I found is 108, and I subtract off the number of protons. Now that looks like a bigger number, so let's go to our calculator to do that. 108 minus 47. So let's clear this out. 108 minus 47. Let's see what it is. 61. If you get worried, you can always double check your math. but 61. So silver has 47 protons, 61 neutrons, and 47 electrons. If you need any help with this, feel free to watch the video again, to pause it, to use these as example problems if you want, and then go ahead on to your homework. Good luck, everybody.